All right, let's look at the 2024 AP Statistics FRQ number 3. As usual, if there are mistakes, I will put in a pinned comment below, so please check that before you just jump into that. There's also a PDF of the solutions that'll be ready in the link too. In the comments. Sorry, not in the comments, in the description. So, car maker produces 4 different models, A, B, C, and D. Group of researchers investigating which model car has the longest distance traveled per gallon. Higher mileage is considered better than lower mileage. Researchers will conduct a study in which they contact several owners of each model car and ask them to estimate their mileage. Is this an observational study or experiment? It's an observational study because we're not controlling or we're not doing anything, so it's an observational study. Because there is no control and treatment. Control treatments or random assignments. That is to say, and we want to do it in the context, so we got to say that is we are not randomly picking people and telling them how to drive, telling them what car to drive. As an example, just to indicate, I just put that in there just to indicate as an example of what a controller treatment might be. I don't really know what exactly how they want it, but that would be the context that I would say. We're not like messing around with people. We're not telling them, hey, you got to drive this car, because other things can factor mileage, right? Like other behaviors and things like that people do. So that's why, a random control is going to be better than just like looking at that. Okay. All right, so Model D has an autopilot feature, which the car controls its own motion with human supervision. James owns a Model D car and will investigate whether using the autopilot feature results in higher mileage than not using autopilot. Okay, so we're going to do that. James will drive his car on 70 different days to and from work using the same route at the same time each day. Okay, James will record the mileage each day. James will use a completely randomized design to conduct his investigation. Describe an appropriate method James could use to randomly assign the 2 treatments, driving using the autopilot feature and driving without using the autopilot feature, to 35 days each. Okay, so what we have to do is we have to, when you're going to do random, you want to ensure that you're going to get 35 it. So a bad thing would be just to flip a coin, because you're not going to guarantee you're going to do 35 days of each. So we are going to use a random number table. So I would say is and you want to assign it. So I'm going to say that if you we'll number days. So the days. Well, let me think what we want to do here. So days. Well, actually, so think of it. We will use a random number table, and the whole idea is I want a 50-50. Well, let me see. What I want to do is I want to go through. So there's 70 total days. So this is what I'm thinking. Okay. So there's 70 total days. Okay. And you can number them. And you can draw 35 out of a hat, right? So we cut up 70 numbers, 1 through 70, pick 35 out of the hat randomly, and then those 35 days will be autopilot, and then the other 35 days will be not autopilot, okay? That would be fine. I'm going to use a random number table, but drawing out of the hat is totally fine, because now we're going to randomly pick which days are going to get those, the autopilot. So I will say, using a random number table, I'm going to, take a random number table, or you can use a random number generator, and group by 2 digits. Okay, 3. If the 2-digit number. Actually, I just use a random number generator. Okay, we just use a random number generator. Right, because randomly generate a 2-digit number. If it is 1 through 70, 0, 1 through 77, and has not been generated before, then that day is an autopilot day. Okay, that would be good. And then repeat until there are 35 days selected. And then last is important, all other 35 days is without autopilot. Okay, so that would work. Drawing numbers out of the hat would work. I mean, there's a lot of answers that you can get away with on this one, so that would be fine. After the investigation was completed, James verified the conditions for inference were met and conduct a hypothesis test. He discovered the mean mileage when using the autopilot feature was significantly higher than the mean mileage when not using the autopilot feature. Okay, James is a member of the Model D Club with thousands of members who all drive Model D cars. He will give a presentation at Model D Club members meeting later this year and would like to state the results of his hypothesis test apply to all Model D cars in his club. Another member of the club, who's a statistician, tells James his findings don't apply to all Model D cars in the club. What change would James need to make to his original study to be able to generalize to all Model D cars? Well, he's going to have to do this with a lot more Model D cars, right? So he would have to, the biggest thing that he would have to make a change to is he would have to do the same thing, but he would need to randomly select several Model D cars randomly and have them perform the same thing. He would need to randomly select several other members who drove Model D cars, and have them perform the same experiment or same test. I don't want to say same test. So the thing is we gotta get a whole select Model D. Like there's a lot of different cars. There's a lot of different traffic patterns. There's a lot of things. We gotta randomly select the owners and their associated cars, right? Because maybe James is doing a lot of highway driving, right? That could be a lot more than someone who's just driving maybe more local driving, right? So then it's a little bit different. So that's why you have to randomly select several other members who drove Model D cars and have them do the same thing. Okay, and that's what I would put for that one.